So trigonometric integrals is yet another technique when you have only sines and cosines in your integral. If it's just sine x, cosine x, we can figure something out. What if you have powers of sine, powers of cosine? I wrote a bunch of cases last time when I first started. Going to generalize now. M here in my notation is the power of sine, n is the power of cosine. So m is odd integer, n is even integer. So the way we approach the problem is to split up sine, cosine, one of the two, and then use an appropriate substitution to come up with the answer. How did we split this up last time? Was this the only case that we did last time?
Yeah.
Okay, how did we split it up?
Yeah, rid of sine q.
How did we get rid of sine q?
We broke it up into sine squared and sine.
Okay. And we have cosine squared x, and what did we do?
We said u is
U equals.
says cosine x.
Okay.
Oh, you meant.
We then said u equals cosine x, which would give us du to the negative sine x dx. So we start with an integral that is fully in terms of x's, and we are going to convert it to an integral that is in terms of u. So u squared, that part's easy, sine x dx, negative du, that is easy. And this part though, not so much. Have sine squared. But our substitution is cosine. This is where the identity is going to come into play. The simplest identity, which is sine squared x plus cosine squared x equals 1. Who's planning on getting to, engineering, calc 3, differential equations, all that fun stuff? Okay, you cannot forget that identity. I don't know if I've mentioned in this class, I always say everything in life goes to one person. Pythagoras. Pretty much. The right hand triangle and the unit circle. End of story, end of life. Good day. Huh? Well, that comes later. Pythagoras did it a long time ago. I mean, Newton used all this stuff, fun stuff, but goes back to a squared plus b squared equals c squared, at least in my opinion. But it is true that we have to convert this sine squared part to cosine squared. So if I rewrote it as 1 minus cosine squared x, rewrite that as u squared. Yes, u is cosine x. So 1 minus u squared times negative du. I want to get rid of negativity. So u squared times u squared minus 1 du. I started with an integral that is in terms of x, had powers of sine, powers of cosine. I ended up writing it as an integral that simply contains algebraic terms. Yes?
Would that be negative to you?
A what?
Negative
It was
d.
1 minus u squared.
Got rid of the negativity.
Oh, yeah,
I like things to be positive. That's just mixed up. Okay, or at least try. So that is type 1. So I guess I'll summarize the types on this side. So I went from powers to writing it as this integral. Is it easier to integrate now? How would you integrate this?
Distribute and then take the integration of both.
Distribute, then take the integral of each time. If that fails, what is your other option?
Could integrate by parts.
Very good. I could do integration by parts. Yes? Okay, so type 1. Oh, I bet sines and cosines. Inside that type 1, I don't memorize these. I go over trial and error, look at the problem, think about it. But if you want a guide, since you're learning, this is your guide. I'm going to use m to be the power of sine, n power of cosine, if m is odd, n is even, your substitution will be cosine x. So you've got to start with a substitution of cosine x, and that will lead you on what to do. Even if you forget that, you can take this approach. I believe that's what I did last time. I started with the wrong substitution. Caden actually had it as cosine x, and I thought, oh no, maybe it's sine x. Could have done it that way. It would make your life really hard. So correct substitution would be cosine x. What would happen if I switch this around? Let's say I make that 4, I make that 3. So m is odd, or even. Same thought process, we've got to split something up. Our goal is to get to sine squared x, cosine squared x. Everything goes back to that one guy, Pythagoras, right? So my objective would be to rewrite this so that I get a squared term, maybe a fourth power, which can be expressed in terms of the square. So naturally, I'm going to split this up and write it this way. Whatever I split up, the substitution must be the opposite of what you split. Well, I did split cosine here, so the substitution will be sine x. Good. With me so far? Yes.
I know, like towards the beginning, the sine squared x sine x, when it becomes 1 minus cos squared x, I'm kind of confused because the sine squared plus cos squared equals 1, but then what about the other sine?
The other sine, I'm keeping it as is so that I can replace it with substitution.
Okay.
Right? That is the objective of splitting that sine.
Mhm.
Same over here. The objective of splitting the cosine is to get an even power so I can use the identity. Good. So one of them's odd. So I did the trick, things worked out. Well, what if I have type 3? M is even, N is even, so what do we do? Split them both count. Now keep in mind, Bryce said split them both, but here's the issue. The purpose of splitting is to get back to that important identity. Sine squared x plus cosine squared x equals 1, right? Even power of sine, even power of cosine. That's what I desire in every single case, which is exactly why I did that, right? Now, what if I start with sine squared x? Let's say something like this. Both of them are even powers. Hint, we've done this before. Without even learning about trigonometric integrals, we have tackled this case before. Sarah, you're shaking your head, do we know? No? Noah, you showed up. You were here on Friday. What, were you? I didn't notice you.
Pretty factor.
Factor? Factor how?
Have a sine cosine on the outside or something. I don't know.
Maybe. Anything else? Do you follow my question? Our entire reasoning behind splitting one term of sine, one term of cosine is to get to that identity sine squared x plus cosine squared x equals 1. It comes from Pythagorean theorem, unit circle. But what if you started with even power of sine, even power of cosine? Splitting that up is going to take back to one of those who make things harder, right? That has to be an easy approach. Hint, we've been doing this for a while without even knowing trigonometric integrals. Hint, it is in that table of integrals that I gave you. The identity, well, which one, Alex?
The.
Half angle, double angle, it's a matter of perspective in my opinion. Technically, it's a double angle identity. I think it's the pessimist optimist thing. Half angle, double angle. Half angle is the pessimistic point of view, double angle is the optimistic point of view. Not giving down about half or double, but getting it right is the realistic point of view. I'm a realist. So I'll just go for double angle, just for fun. But it doesn't matter how you call it, how you write it. Sine squared x is 1 minus cosine 2x divided by 2. Yes? Cosine squared x will be 1 plus cosine 2x over 2. And once we rewrite it in terms of the identity, then life's easy from there on. Yes? Now, what would happen if you had higher powers? Yeah, it does get painful. But that is the nature of things. Okay, what if both of them are odd? Do you follow my question? What if both of them are odd? You have sine cubed x, cubed x. I call that type 4. Which one do you split up? Or does it matter which one I split up? If both of them are odd. Here we split up the sine power so that we take the opposite of that sine power as substitution. There, the power of cosine. Here, double angle identity. What if both of them are odd? What do you do? Should you pick cosine x? Should you pick sine x? I love sin. So I'm just going to go for sine A. Now, would it matter if you pick cosine? No, it doesn't. Answer will still be the same, but I don't want to be the co of anything when I'm committing sin. So I'd rather go for sine A. But you might disagree, and you can pick cosine. It's up to you. Yes.
You wrote that as double angle. They're actually in the formula sheet. You have it as half angle.
Were you paying attention about the optimist, realist, and pessimist? You did. Double angle, half angle, it's a matter of perspective, right? Whether you call it half, whether you call it double, in my opinion.
Because like you have both of them in the formula sheet, and then that's how it's written.
So if this were to be x, that would be x over 2, right? Then people would say half angle. So to me, it is a matter of perspective. I'm a realist. I don't care whether I call it double or half. I just know what to write. Good? Okay. Are we clear with that part? That's a bit of philosophy, put in with trigonometry, and some theology too. So it doesn't matter whether you pick sine, cosine, when it's odd, even. I like to go with sines, but cosine's fine too. Now, depending on your choice, your answer will differ. Agreed? Depending on the substitution that you pick, the answer will change. But they are equivalent. Agreed? So how to know or how to go from one to the other? We've been through this already. I asked the question last week, relationship between sine and cosine. We call it cosine for a reason. It is what completes sin. Complementary sine. Okay. Complementary angle, if you put the complementary angle, you can write it in terms of cosine. Good? So you can go back and forth, but knowing that the answer will be different is key, so that you don't freak out. It has to occur to you right away. Your choice of substitution here is going to change the answer a tiny bit. Good? By tiny bit, I mean instead of having it in sines, you may have it in cosines. Instead of having it in cosines, you will have it in sines. Okay. That leaves us one more time, and then we can do examples. Erase. Last case. Let's say you don't have powers. Rather, you end up having sine AX cosine BX. Now, if that was sine AX, this was cosine AX, then the problem is easy. Do you agree? A simple U substitution followed by double half angle, one of those two, and you get the answer. But that is not the case. A is not equal to B. What do we do in a case like that? That's where this comes into play. What is sine A plus B? Sine of A plus sine of B. What?
Sine A cosine B plus cosine A.
How does that table happen?
It's beautiful.
Sine A cosine B plus cosine A sine B. I'm sure there's a name for this. Product to sum to product. Again, it is a matter of perspective. There is a product, there is a sum, depending on how you see it. Minus here, it'll be a minus there, that's what. The next case is cosine A plus B, A minus B, cosine A, cosine B, minus sine A, sine B. If it is plus over there, it is minus here, it's minus over there, it's plus here. It's the opposite. And it's type 5. So you move from having something that is a product right over here, and you rewrite it in terms of cosine A plus B, cosine A minus B. Good. I would write this as an type now, and when we have a problem, I'll show you how we can go about doing this. If you simply have two angles that are matching, in other words, you have 3x, 3x. Should you use this identity? Sure, you can. Will you get the correct answer? Absolutely. But it's eating a sandwich this way. You can simply use a different identity and go for a direct bite. Good. It's a matter of choice. That will work for pretty much any problem. Are we clear? Good. So that is the introduction part for the 5 types of sines and cosine. Again, personally, I don't memorize these. I go with the flow. I hope you take a similar approach.